part C, we're going to graph g sub 1 of x is equal to 1/4 times the absolute value of x. So this is going to be the parent function, the absolute value of x. And notice that 1/4 is on the outside of the function. So that's going to be a vertical. And then remember, if it's less than 1, or less than the absolute value of 1, the vertical will be a vertical shrink or compression. So it's going to be compressed by 4, or by 1/4. I'm okay if you say it that way as well. So that means my y's are going to be compressed. So they'll be 1/4 of the size. So we know with our absolute value parent function, we have the point, and I'll go ahead and use these 3 points. So we've got -2, 2, 0, 0, and 2, 2. So if I take my y values and I shrink them by 4, my new y values, I'll do that in pink. So my g sub 1 of x, well, it's not letting me write that. Take that y2 and divide it by 4. And we get 1/2. 0 divided by 4 is just 0. And then 2 divided by 4, again, is 1/2. So I still have this point at 0, 0. And then I have a point at 2, 1/2. So this is 1, then here's 1/2. And then -2, 1/2. Okay, and we could do some more points. For now, I'm good with those. Oh, so this should be in pink. Okay. Looking at the next one, the graph of g sub 2 of x equals -3 times the absolute value of x. Now there's two different things happening here. Remember, the negative does one thing, the 3 does another. So the negative is going to be a reflection. And think about it, if it's outside of the function, it's affecting your y values. So your y values are going to become negative. Think about if you start with positive y's, and then they become negative, you're reflecting over the x-axis. So reflected over x-axis. And the order on this doesn't actually matter, whether you do the reflection first or the stretching first. And then the 3. So we're looking at the absolute value of -3. So we're just looking at the 3 only. That is going to be a vertical stretch because it's larger than 1. So we're stretching by 3, reflecting over the x-axis. Alright, so if I look at these points that I already have here, my g sub 2 of x, so my new y values, instead of 2, we'll start by doing the stretching by 3. So I'm going to multiply 2 times 3 and I get 6. So that's just taking this point here from the parent function and multiplying the y value by 3. Alright, then I can do my reflection, so it's going to be a -6. Alright, my next point, 0, 0. Multiply 0 times 3 and I get 0. Make it negative, it's still 0. And then that point 2, 2. Multiply that 2 by 3 and I get 6. And then make it a negative. We get a -6. So I still have this point at 0, 0. I'm going to go ahead and write my x's from the original point, so -2, 0, and 2. My x's aren't changing. So I've got a point at -2, -6, and a point at 2, -6. So you'll see this is stretched vertically because it's getting taller and skinnier, but then it's also reflected over the x-axis. Okay, in D, now my 1/4 is inside the function. So remember, that's affecting my x's, anything inside the function. And then if it's inside, it's also inverse. So you would think if you're multiplying by 1/4, that's a shrink, but really it's a horizontal stretch by 4. Okay, so if we have our same points from the parent function, and I'm going to stretch it horizontally. That means that I'm actually changing my x values. So my new x, instead of a -2, I'm going to multiply it, since I'm stretching, multiplying it by 4. So -8, my y value stays the same. That point 0, 0, 0 times 2 is, or times 4 is still 0, so it stays 0, 0. 2 times 4 is 8. My y value stays the same. So here's my new points for g sub 1 of x. I've got -8, 2, 0, 0, and then 8, 2. So this thing is stretched horizontally. And then g sub 2 of x. Alright, we've got a -4 inside the function. Remember, the negative does one thing, the 4 does another. So the negative is going to give me a reflection. Think about it's making my x's go from positive x's to negative x's. So it's reflecting over the y-axis. And then the 4 is where I'm going to have my horizontal compression, because 4 is larger than 1. So we're going to do the inverse, and we're going to compress by 4, reflecting over the y-axis. Okay, so what that's going to look like. I'm going to take my x values, that -2, 0, 2, and I'm going to compress by 4. So -1/2, 0, 1/2. I'm dividing them each by 4. Alright, then I can do my reflection over the y-axis. So that means my x values are going to change signs. So this becomes 1/2, 2, 0, 0, and then -1/2, 2. So here are the points I'm going to graph. Alright, if this is a 1, 1/2 is here. It's -1, so -1/2 is here, and we still have that point at 0, 0. So we just got a nice tall skinny graph. And this is a horizontal compression. It's being compressed horizontally.